coolant in, everything, and we got it up to speed, but we did have some warning lights on the dashboard that we need to get off. We've got the airbag light due to one thing, which we think is the pyro fuse, but there's two pyro fuses on here. One, we've learned, cuts the power to the starter motor when all the airbags gone, but for some reason that didn't blow in the accident. But I don't actually think it's damaged. Oh yeah, it's damaged. Oh! Jeez! Why did it spark?
Oh my god.
Most people have never heard of a pyrofuse, which is exactly why this story matters, because most people have one in their car right now without knowing it. A pyrofuse is a safety device, a small explosive charge triggered by the same crash signal that fires your airbags that physically severs the connection between the battery and the rest of the car's electrical system. Not switched off electronically, physically cut, instantly. Why does that matter? Because a car battery sitting inside a crashed vehicle is a serious fire hazard. The battery stores enormous energy. Damaged wiring creates short circuits. Short circuits generate heat. And heat inside a vehicle that's just been in a collision, with fuel potentially leaking, with components displaced, is exactly the combination that produces post-crash fires. The kind that kill people who survived the initial impact. The pyrofuse eliminates that risk at the source. The moment crash sensors detect a significant impact, the same moment the airbags deploy, the pyrofuse receives a signal. The charge fires. The battery circuit is cut. The car loses electrical power immediately. This is one of the reasons modern vehicles can survive crashes that would have been fatal to occupants of older cars, not just because of airbags, but because of everything working alongside them. The Bugatti Chiron has two pyrofuses. One cuts power to the starter motor. One cuts power to the entire electrical system. Both should have fired when this Chiron crashed. Neither did. Matt explained on the second channel why the pyrofuses didn't fire. On most Volkswagen Group cars, Lamborghinis included, when there's a crash, the pyrofuses cut power immediately. Sometimes so fast the airbags don't even deploy. On this Chiron, the opposite happened. Every airbag deployed correctly. The crash was detected. The system responded, but the pyrofuses did not fire. His exact words, "Something is not quite right there. Maybe there was some kind of fault or mistake or something." And then he said something that reveals the specific logic behind all of this. I guess that is a bit more convenient for when you need to drive it back. Think about what that means. A car that has just been in a serious collision, airbags deployed, significant structural damage, still has full electrical power because the pyrofuses didn't fire, which means it can be started and moved. Whether that's a deliberate Bugatti-specific calibration, a conscious decision to prioritize limited drivability after a low-speed incident, or simply a fault in this particular car's pyrofuse circuit, nobody outside Bugatti knows for certain. What is clear is that when Matt went to fix the faulty pyrofuse, he opened the housing and found a Mercedes-Benz unit inside. And that discovery is the most revealing thing to come out of this entire rebuild. Why Bugatti uses a Mercedes Sprinter part? Matt said it on camera, plainly, "I do not know why they are using Mercedes-Benz pyrofuses." The answer isn't complicated. It's just uncomfortable for Bugatti's pricing model. Mercedes-Benz produces one of the most well-regarded pyrofuse designs in the automotive industry. Their safety systems are tested to the highest standards, thoroughly documented, and available at volume pricing, because Mercedes produces hundreds of thousands of vehicles every year. Bugatti produces approximately 40 to 50 cars per year. At that production volume, developing a proprietary pyrofuse from scratch isn't just expensive, it's economically absurd. You'd need to design it, validate it against safety standards, certify it, and manufacture it in quantities so small that the per-unit cost would be enormous. So Bugatti didn't do that. They used Mercedes-Benz. And this isn't an isolated decision. This is a pattern that runs through the entire car. During this rebuild, Matt has found an Audi A3 airbag control module, a Volkswagen Phaeton secondary air pump, Porsche crash sensors, a Lamborghini Gallardo fuse board, and now a Mercedes Sprinter pyrofuse. Every single one of these is a shared component. sourced from elsewhere in the broader Volkswagen Group supply chain or the wider industry, chosen because it meets the required specification reliably and at a fraction of what a bespoke Bugatti part would cost to engineer. This is not a scandal. This is how low-volume hypercars actually work. The £3 million price tag on a Bugatti Chiron is not a reflection of what's inside the parts bin. It's a reflection of what those parts are combined into. The W16 engine, genuinely unique. The quad-turbocharged, 8-liter, 16-cylinder powertrain is not shared with anything. The carbon fiber monocoque chassis, the all-wheel drive system, the aerodynamics capable of managing airflow at over 300 miles per hour, all of that required engineering that exists nowhere else. That is where the money goes. The Pyrofuse is a Mercedes Sprinter part. Because the physics of battery disconnection in a crash don't care whether the car costs £30,000 or £3 million. The charge needs to fire at a specific current, cut a specific circuit, within a specific time window. Those requirements are identical in a panel van and a hypercar. So Bugatti solved that problem once, with a component that already solved it, and spent the engineering budget somewhere it actually mattered. Matt sourced a replacement. A 2019 Mercedes Sprinter Pyrofuse, found locally in Miami. Correct year, correct model, correct component number. He spent time preparing the installation, opened the original housing, extracted the internal unit, transferred the new fuse in, soldered the connection, applied heat shrink, installed the assembly, and tested it. The airbag light stayed on. His words, "We got scammed." The supplier had sold him a Pyrofuse from a crashed Mercedes Sprinter. A component that had already been in a collision. A component that had, almost certainly, already fired. Here's the problem. A fired Pyrofuse looks identical to an unfired one from the outside. The internal explosive charge is depleted, but the housing is intact, the terminals are intact, and the component passes a visual inspection without any issue. You only discover it's already fired when you test it in a live circuit, when you expect it to report a specific resistance value, and it doesn't. The supplier almost certainly didn't know. Hard parts salvaged from crashed vehicles are standard practice in the automotive recycling industry. A Pyrofuse pulled from a crashed Sprinter is cataloged as a Pyrofuse. Whether its charge has already been expended isn't something most salvage yards document, because in almost every other application, it doesn't matter. With a safety-critical component like this, it's the only thing that matters. Matt didn't get scammed by dishonesty. He got caught by a gap in how salvage parts are cataloged, a gap that exists across the entire automotive recycling industry, not just in Miami. And it cost him hours of work and pushed the IVA date further away. Here's why the faulty Pyrofuse is the single most important remaining problem on this car. Before this Bugatti can receive a UK number plate, before it can be driven legally on a public road, it has to pass the Individual Vehicle Approval Inspection, the IVA. A comprehensive roadworthiness check covering safety systems, lighting, emissions, and build quality. One of the things an IVA inspector checks is warning lights. Specifically, whether any are illuminated on the dashboard. The airbag light is currently on. Not because of the airbags themselves. Not because of the sensors. Not because of anything Matt, Bob, or anyone at E3 Customs installed incorrectly. Because a Pyrofuse from a crashed Sprinter is reporting the wrong resistance in the circuit, and the car knows it. Matt can't fix this before he leaves Miami. He has temporarily reinstalled the original fuse, zip-tied into position, to clear the light for now. But that is not a permanent solution and it won't pass inspection. When he comes back, the correct replacement unit will be fitted properly. The fault will clear. The light will go off. There's one more detail here that most people don't know about Pyrofuses. Once you fit a new one, you cannot test whether it will actually fire in a real crash without firing it, which destroys it. The standard procedure is to confirm correct resistance in the circuit. If the resistance reads correctly, the Pyrofuse is assumed functional. That assumption is the entire basis on which every car manufacturer signs off these components. Which means the only true test of whether a Pyrofuse works is the moment you need it to work. And the only way to know it didn't work is when it doesn't. This is why the correct, undeployed component from a verified source matters. Not approximately correct. Exactly correct. With confirmation it has never been fired. The correct unit is on order. When it arrives and gets fitted, the airbag light goes off, the IVA gets booked, and a Bugatti Chiron built from components sourced across 8 different manufacturers goes onto a public road with a UK number plate. A £3 million hypercar. Delayed, not by structural damage, not by the welding, not by the Honda Civic radiator cores, by a 100-pound fuse from a crashed van that nobody documented as already fired. The correct Mercedes fuse is on order. The custom panels are being made. The color still hasn't been revealed. And a Bugatti with parts from 8 different manufacturers is weeks away from a number plate.